Give the structure and names of the products of the reactions below. Now again, examination technique. Read the question fully, give the structures and names. Here you were not likely to forget it because they had these boxes drawn up for the reactions below. These reactions are carried out by heating in either, this stuff here is what we are beginning with, right? And you can see clearly that that's an ester. There's the ester functional group. C double bond O with the rest of the molecule on either side. And incidentally, while we've got it there, we would be naming that as propyl methanoate. That's the ester that we begin with. And if you warm it up with dilute hydrochloric acid solution, here on the left hand side, what are the products that you get? And the separate other possibility is that we warm it up with dilute sodium hydroxide solution. Now it says give the structures and names of the products of the reactions below. By that they mean the organic products that we are going to draw. Okay, and then it says at the bottom, compare and contrast the reactions above. In your answer, you should include the type of reactions taking place. The dilute hydrochloric acid, what does it do? Both of these reactions breaks the ester link. It's going to separate out the alcohol part and the acid part. So both the reactions produce propan-1-ol in common, the alcohol part. But the difference is, with the acid, when you break this up, you'll end up producing the acid part here was from methanoic acid. You'll end up with methanoic acid. But with the dilute sodium hydroxide, you can think of it like this, that methanoic acid gets produced first. This is under strongly alkaline conditions. And what will that do? The sodium hydroxide would react with the acid. So the methanoic acid is not going to stay there as methanoic acid. It will convert it into the sodium salt of the methanoic acid, which is going to be sodium methanoate and water, or if you like, just the methanoate ion. That's going to come into the comparing and contrasting. What's similar, what's different between the reactions above. I've kind of talked about it now, but we can then go over and look at the answer to these. So firstly, with hydrochloric acid on the left hand side, look at this, we get methanoic acid. So write it down in the name there, methanoic acid, right? Acid hydrolysis of the ester. So breaks it up into the free acid and the alcohol molecule. So that will be methanoic acid as the acid. And what is the alcohol? Here it's going to be the 3-carbon alcohol here, right? The 3-carbon alcohol. That will be with the OH on the end carbon, which means we will name it to make that carbon the minimum number, because in here the OH is the principal functional group. There's no other functional groups in that part of the molecule. So we name it as an ol, propan-1-ol here when the OH is on the end carbon. Propan-1-ol. Why does the chlorine from the HCl not react with the acid to form an acid chloride? Good question. Edward is wanting to know why, when you break up the ester, does it not form the acid chloride, which would then be not this OH here, but with a Cl, methanol chloride. Producing an acid chloride from an acid is not easy. The Cl cannot react with it just like that. You need one of very special reagents to do that. That would be either thionyl chloride, SOCl2, or phosphorus pentachloride, PCl5, or PCl3, phosphorus trichloride. They are highly reactive compounds, SOCl2, PCl5, or PCl3. And they are strong enough to knock that OH out and put the chlorine there. That's certainly not going to happen if you take a alkanoic acid, for example, and warm it up with a sodium chloride solution. No, that's not going to happen. Okay, see, on the other hand, these acid chlorides are very highly reactive compounds. We'll come across those in just a moment, very soon in fact. And acid chloride will easily react with water to give you the acid and HCl, right? The other way around it goes easily. When I came across this for the first time, I was so impressed with this. I can still remember the SOCl2, right, that compound there, the thionyl chloride, that it could do this. I took a sample bottle and took some home, thionyl chloride, right, and it's a colorless organic liquid, right, SOCl2. Okay, and that can knock this out and put a chlorine there. So you can easily go from the acid chloride to the acid, but not the other way around. Okay, so I've named those two products, right? Methanoic acid and propan-1-ol. Now what happens when you warm it up with dilute sodium hydroxide solution? Again, the ester linkage is broken and you will produce the propan-1-ol, still the same as with the other one. The only difference being, rather than getting the free acid, you will get its salt form. And if you are using sodium hydroxide, you will get the sodium salt. So that would be called sodium methanoate. The important thing is you get the methanoate ion, not the free methanoic acid. Why? Because you can think of it as though base sodium hydroxide then reacting with the initial acid that gets formed. So you get here the name for this, sodium methanoate, and once again, of course, propan-1-ol. Okay. Any question up to there? I'm about to discuss this last part here. Now, it says compare and contrast. And again, examination technique. Make sure you read these carefully so that you address everything that is required. Compare and contrast the reactions above. That's these two reactions, with the acid and with the base. In your answer, you should include the type of reactions taking place. So you must see, don't forget little things like that and unnecessarily lose marks that are easy to collect. Both the reactions involve hydrolysis of the ester linkage. That's what is in common to both of them. And in both cases, propan-1-ol is the alcohol that is produced. However, the difference is that under acid conditions, free methanoic acid gets produced, while under alkaline conditions, the salt of the acid is the result. So in as far as the alcohol is concerned, you get the same product. But under acid conditions, you get the free acid. Under alkaline conditions, you get the salt of the acid.